Welcome back to our blood transfusion science course. In Module 1, we laid the foundation by exploring blood group systems, grouping techniques, antisera, anticoagulants, and donor screening. Now, we move into the practical, operational, and quality-focused aspect of transfusion science. We will look at preparation of different blood products, storage requirements for each product, how blood banks are organized, quality control procedures for reagents and facilities, hands-on laboratory practices such as antibody screening and titration. By the end of this module, you should be able to describe how a blood bank operates from donor to recipient, explain the storage and handling of blood products, and perform critical quality checks. Section 1. Preparation of blood products. 1.1 Why separate blood into components? Whole blood can be separated into different components to maximize the use of each donation, meet the specific needs of patients, reduce the risk of transfusion complications. 1.2 Key blood components and how they are prepared. Cryoprecipitate. Rich in clotting factors such as fibrinogen, factor 8, factor 13, and von Willebrand factor. Prepared by slowly thawing frozen plasma at 1 to 6 degrees Celsius and centrifuging to collect the precipitate. Platelet-rich plasma, PRP. Obtained from whole blood by light centrifugation. PRP is then further processed to isolate platelets. Packed red cells. Prepared by removing plasma from whole blood through centrifugation. Used for patients with anemia or blood loss. Fresh frozen plasma, FFP. Plasma separated and frozen within 8 hours of collection. Contains all clotting factors, used for coagulation disorders. Fibrinogen concentrate. Derived from cryoprecipitate or specialized fractionation processes. Used in patients with hypofibrinogenemia. 1.3 Steps for blood component preparation. Collect blood into anticoagulant-containing bags. Centrifuge using appropriate speed and temperature. Separate components in a closed system to maintain sterility. Store each component under its specific conditions. Section 2. Storage of blood and blood products. 2.1 General principles. Maintain cold chain integrity. Use dedicated refrigerators, freezers, and platelet agitators. Monitor temperature continuously. 2.2 Storage requirements. Whole blood. Temperature, 1 to 6 degrees Celsius. Shelf life, 35 days with CPDA, 1. Packed red cells. Temperature, 1 to 6 degrees Celsius. Shelf life, similar to whole blood. Platelets. Temperature, 20 to 24 degrees Celsius with constant agitation. Shelf life, 5 to 7 days. Fresh frozen plasma. Temperature, minus 18 degrees Celsius or colder. Shelf life, up to 1 year. Cryoprecipitate. Temperature, minus 18 degrees Celsius or colder. Shelf life, up to 1 year. 2.3 Advantages and disadvantages of storage methods. Refrigeration preserves red cells but not platelets. Freezing preserves plasma proteins but requires expensive equipment. Room temperature with agitation is necessary for platelets but increases bacterial growth risk. Section 3. Blood bank organization and records. 3.1 Organizational structure. A functional blood bank typically includes donor recruitment unit, mobilizes voluntary donors. Collection unit, collects and labels blood. Testing unit, performs blood grouping, cross-matching, and infectious disease screening. Component preparation unit, separates whole blood into components. Storage and inventory unit, maintains stock and manages distribution. Quality control unit, monitors compliance with standards. 3.2 Facilities and equipment. Refrigerators with temperature alarms. Platelet incubators and agitators. Blood bank centrifuges. Deep freezers for plasma and cryoprecipitate. Microscopes and serological workstations. Backup power supply. 3.3 Records management. Donor records, personal information, donation history. Test results, blood group, infectious screening. Inventory logs, stock levels, expiration dates. Transfusion records, recipient details and cross-match results. Section 4. Blood group-specific substances. 4.1 Synthesis and identification. Certain body fluids, such as saliva, contain blood group substances in secretors. Identification involves using specific antiserum and precipitation methods. 4.2 Applications. Forensic science, identification of individuals. Resolving discrepancies in blood grouping. Research in immunohematology. Section 5. Quality control in blood transfusion science. 5.1 Importance of quality control. Ensures reliability of test results. Prevents transfusion-related accidents. Maintains compliance with regulatory standards. 5.2 Quality control of reagents. Test antisera for potency, avidity, and specificity. Monitor expiry dates and storage conditions. Perform parallel testing with control samples. 5.3 Quality control of equipment. Calibrate centrifuges and thermometers regularly. Maintain clean and contamination-free work areas. Use temperature monitoring charts. Section 6. Practical/tutorial applications. 6.1 ABO and RH grouping method. Forward and reverse typing. Controls to detect false positives/negatives. 6.2 Antiserum titration. Perform serial dilutions. Record the highest dilution that produces agglutination. 6.3 Direct Coombs test, DCT. Detect antibodies or complement bound to red cells in vivo. Used in hemolytic disease of the newborn and autoimmune hemolytic anemia. 6.4 Indirect Coombs test, ICT. Detect antibodies in plasma that may react with donor red cells. Used in cross-matching. 6.5 Antibody screening. Performed using commercial screening cells. Detect clinically significant antibodies before transfusion. In this module, we have covered how blood is processed into different components, optimal storage conditions, the structure and operation of a blood bank, methods for quality control, practical laboratory procedures that ensure safe transfusion practices. Together with Module 1, you now have a complete and detailed understanding of blood transfusion science, from blood group genetics to blood bank management.